Do you know the architecture which is doing a lot of rounds in building LLMs right now? So far, we have heard transformers doing all the rounds, but there are a lot of issues with transformers. Right now, transformers in transformers architecture, all the tokens go through each and every layer. Now, what does that mean? That means the memory is inefficient. You need to have extensive compute power, and the training it also takes a lot of time. Now, to address all of these problems, Google DeepMind have released a new paper called Mixture of Recursions. Now, what does this architecture actually do? Now, think of it as rather than going through all the layers for the tokens, let's say we have a intelligent router which actually decides which token to go through and which token to be skipped. Now, what that router kind of does is it identifies which are the simple words which does not need to go through multiple layers and which are the complex words which kind of need to go through multiple layers to identify what needs to be the next word. Now, what that would mean is that your memory becomes more efficient, your KV cache becomes more efficient, your inference is faster, you need less compute, and that's exactly what mixture of recursions actually does. Now, what mixture of recursion pretty much tells you is it kind of dictates you will have two routers. One is an expert choice router, one is a token choice router. Now, the expert choice router would actually decide which token to go to the next layer and which token to get skipped. Now, the token choice router actually uses the tokens to kind of do recursive process and identifies does it really need to go to the next layer or not. Now, what this would also mean is that your parameter size is also quite less, and there is a model on with a mixture of recursions which is trained on a 118 million model and which is able to kind of in terms of benchmark defeat the 350 million model in terms of transformers. So is that going to replace the transformers architecture? Let's wait to find out.